All right, we are on page 293. This video is going to cover until page 297, which will be the last topic, last topic and also last lesson in this module. So we'll be taking our test on this topic pretty soon. Anyways, activity 2 is focusing on standard form. So standard form, it looks like this, right? We worked on slope-intercept form, point slope form, and standard form. Where we have it's ax plus by equal to c, and this is where a, b, and c, these are just constants or just numbers. Okay, so we still have our independent and dependent variable. We're going to look at this situation, then explain what these parts of this equation look like. It says tickets for a school play cost $5 for students, $8 for adults. On opening night, the school collected $1,600 or $1,600 in ticket sales. So we have this equation that models the situation, right? 5x plus 8y equal to 1,600. So what does each part represent? So we'll write that here. So number one, 5x. 5x represents the cost of student tickets. Student tickets, we'll say times number of tickets sold. I'll just say number sold. Right, since it's $5 per ticket, it's 5 times x. And we have y representing for adults, so 8y represents the cost of adult tickets times how many adult tickets were sold. Right, so since it's $8, right, if 2 adults bought it, 8 times 2, okay. And 1,600, this represents the total amount, we'll say collected. All right. And then for number 2, it says, what is the independent and dependent variable? Typically, we say x is independent and y is dependent. But in this context, either variable could be independent or dependent. The reason is because adult tickets aren't really dependent on student tickets or vice versa. So we're going to say either could be independent or dependent. So I could have put 5y instead of 5x, and it could have been $5 per each student ticket, and y would represent adult instead of student. Okay. All right. Anyways, we're gonna continue this context on the next page and talk about key vocabulary terms. So page 294. We're talking about the y-intercept. So the y-intercept, this is where x is 0, and this is a point on the line that crosses the y-axis. What we haven't really talked about too much is, for this, to calculate the y-intercept, you substitute 0 in for x and you solve for y. Vice versa for the x-intercept that we haven't talked too much about, this is where the line crosses the x-axis, right? So the value of y is 0, and how we can calculate the x-intercept is you substitute 0 in for y and solve for x. So we're going to be solving equations here. But let's look at number 3. So calculate and interpret the meanings of the x-intercept and the y-intercept for this equation. All right, so that was, let's rewrite the equation. 5x equal to plus 8y equal to 1,600. If you were to solve for the x-intercept, right, we would say y is 0. So this whole thing would be 0 here. So to find the x-intercept, you would divide both sides by 5. Okay, I'll write this out to the side. So 1,600 divided by 5. If you complete that, that is 320. Okay, but let's go and interpret that. So the x-intercept, this is where y is 0. That's the coordinate. Since the x-intercept is 320, it'll be 320 comma the y value is 0, so comma 0. And then for the y-intercept, you set x equal to 0, so all this is 0. And you would divide both sides by 8, so you do 1,600 divided by 8. And 16 divided by 8 is 2. Let's add 2 zeros here, so that's 200. Okay, so we'll say y-intercept, that's where x is 0. And since x is 0, we'll put 0 here and 200 here. Okay, so what does that represent? The x-intercept means that when the student sells 320 tickets, then it does not sell any adult tickets. So this would be only sold tickets. I'm gonna put TIX to students. And this would represent, right, 0 for students and 200 for adults. So only sold tickets to adults. Okay, so that's what that represents. Now, what's nice about this is we can graph this. So number 4, use the x and y-intercept to graph the equation of the line. You just need 2 points to graph a line. So here, let's find the y-intercept. The y-intercept was 0, 200. 0, 200 is right here. And then the x-intercept is 320, 0. So that's right here. So you just need to connect those two dots here, and this gives us right, the line that models this situation. Okay. Anyway, so that's pretty much it for that. Number 5, determine the slope of the line. Right, we can use any point here. We can find the rise and run. I could use the 2 points that I have, but I see that it crosses like this point here. So what if we go down and to the right? Okay, what is this going by? This is 80. So this is going down 40. And this is going to the right. That is 80. So this is 60. One second. Okay, 40, 60. All right, so this is negative 40 over 60. We can simplify this to be negative 4 over 6. And then further simplify this. You could divide both of them by 2. This would be negative 2/3. Okay, so this would represent the fact that the number of adult tickets sold decreases for every 2. Decreases 2 for every 3 student tickets sold. So, all right, since we have y is represented as adults, right? If you look at the y-axis, it says adults, over students. So number of adult tickets decreases 2 for every 3 students. So what that means is for every, you could think of like 2 parents, there's 3 kids that are going to this event. Okay. All right, and then let's go ahead and move on to the next page. All right. Now here, I'm gonna walk through the process of the first one, but then we'll talk about the answers for each one. So this would require us solving quite a bit of equations. So it says for number 6, for each equation, determine the x-intercept, y-intercept, and the slope. So to determine the x-intercept, remember y is 0. And if you divide both sides by 5, the x-intercept would be 6, 6/5, 0. All right. For the y-intercept, that's where x is 0. If you divide both of these by 2, right, 6 divided by 2, that's 3. So that would be 0, 3. Okay. And then in order to find the slope, to get this in slope-intercept form, you'd have to subtract 5x to both sides and then divide both sides by 2. So if you did this, 5x minus 5x, right, that would be 2y equal to negative 5x plus 6. And if you divided both sides by 2, this is the slope right here, because that would be y equal to negative 5/2 x plus 3. So in this case, it's negative 5/2. Okay, so I'm going to put m equal to negative 5/2. Now I'm not going to do that for each single one because we're supposed to be noticing something, but I'll at least give you the answers for the remaining ones. But you're welcome to pause the video and try to figure it out before I give you the answer. For the second row, we have 7 thirds, comma 0, 0 and 7/4. The slope is a negative 3/4. I'll do one more. We'll get rid of the last one. This is 9/2, comma 0, 0, comma negative 3, and m is equal to 2/3. Okay. Now, I want you to see if you can notice any patterns between the three examples. So hopefully you've paused it. You try to figure out, right, the slope, the y-intercept, and x-intercept here. Keeping in mind that standard form is ax plus by equal to c. What can we do instead of solving three different equations, or solving for three different variables? Because that takes some time. The x-intercept, if you think of this, the x-intercept is taking c divided by a, comma 0. So it's whatever this value divided by this value, comma 0. That's always for the x-intercept. So keep that in mind. All right, and that's what we did here, right? We did 6 divided by 5, 6/5. 7 divided by 3, 7/3. 9 divided by 2, 9/2, right? So all of that works out. What's the pattern for the y-intercept? Something similar, but it is 0, the y-intercept, x is 0, and it is c over b. Right, so c over b, so this value divided by this value. So that's what we got here. 6 divided by 2 is 3. 7 divided by 4 is 7/5. 9 divided by negative 3 is negative 3. Okay. All right. And then the last one, there was a little bit more nuance to it. The slope was always negative a over b. So whatever a over b is, change the sign. That's what that negative sign means. So in this case, right, it was always this value divided by this value. So here, 5/2. Yep, we see that here, but it's negative 5/2. 3/4, yes, but it's negative 3/4. 2 divided by negative 3, yeah, but we changed the sign, so it's just 2/3. Okay, so 2 divided by positive 3. So that's what we have to do here instead of solving for varying equations. Okay, all right. So we're going to use that understanding to help us with the slope for number 8. To match each graph with the correct equation written in standard form. So they all have the same thing in common. They all have the same y-intercept. But let's look at which one is which by looking at the slope. The slope for A is 3 over negative 12, but change the sign. So it's 3 over positive 12. If you simplify this, divide both of them by 3. This is 1/4. Okay, that looks like 1/4 isn't that big of a number, so it's not that steep. This would be 6 over negative 2, but let's change it. 6 over positive 2. That's equal to 3. And then the last one, 9 over negative 9, but 9 over positive 9. So that's equal to a positive 1. So the steepest line, line 1, is whichever number is biggest. 1/4, 3, and 1. We would say 3 is the biggest number out of those three. So line 1, it has the equation 6x minus 2y equal to negative 10. The next one is 1 is bigger than 1/4, so this would be line 2. And the last one is the smallest number, so it's the less steep slope. It is line 3. Okay. Anyways, so that's all we had to do there. Let's move on to the next page, and that is page 296. We're going to go through one context. We're going to skip number 10. We'll see that this is a you-do. Okay, let's read the context first. So it says define variables for each situation, then write an equation standard form and use the intercepts to graph the linear relationship. So we're going to find the x-intercept and y-intercept. Number 9, Ashley burns 20 calories every 5 minutes. And she minutes she jumps rope, and 50 calories for every 5 minutes she runs. On Tuesday, Ashley burns a total of 500 calories. Okay, so just gotta be careful with that. So we have two variables, x and y. It doesn't matter which one you let represent which. The thing that is a variable here is 5 minute increments. Ashley jumps. We'll say Ashley just. We'll say this represents her. Was it jumping rope? Jump roping, whichever one. I don't know. Jumping rope, and y is going to represent how the length of time that Ashley runs. Okay, right. That 5 minute increment, that's actually not important. That's what we call as a red herring. A red herring is extra information that's not useful. So if we were to write this, ax plus by equal to c, the equation would be x represents jumping rope. She burns 20 calories jumping rope, so that's 20x. Y represents how much she runs. She burns 50 calories every 5 minutes that she runs. And then on Tuesday, she burned a total of 500 calories. Okay. Let's go ahead and label our axes here. Since we're saying x is jumping rope, I'll just put rope here. And then we'll put for the y-axis, this is running. I'll just say run right here. In order to find the varying intercepts, we do have to label our x and y axis. Let's say we'll go by increments of 2 here. So every 2, we'll put a tick mark, but so we're not going to write every 2. We're going to skip count by 4 for every 2. So this will be 4, 8, 12, 16, 18. Oh, whoops, not 18. 20, 24, 28, 32, 36. We'll end up at 40. And then for running, we'll do the same thing every 2 ticks. So we are going by technically 2s here, but I'm labeling every 4, just so it doesn't take us forever to write everything. You know what, I'll do this. I'll start at 4. We know that the next one is 8. I'm going to go up here for 12. We know the next one will be 16, but I'll go up here for 20. Next one is 24, but I'll go up here for 28. Next one is 32, but I'll go up here for 36. Okay, we still get the right idea. We don't have to label every single one. All right, so for the x-intercept, I'm going to annotate on here and then erase as we kind of go on. X-intercept, the y value is 0. So this is 0. If you divide both of these by 20, the x-intercept is whatever 50 divided by 20 is. Okay, so let's 50 divided by 20. Yeah, I'll put it over here. Or sorry, 500 divided by 20. They both end in 0, so whatever 50 divided by 2 is, that's 25. So it's x comma 0, it'll be 25 comma, x comma y, it'll be 25 comma 0. So 25 comma 0 looks like 25. This is 26 right here, so 25 is right here. All right, now let's find the y-intercept. That's where x is 0. So this is all 0. If I divide both sides by 50, our answer for the y-intercept is whatever 500 divided by 50 is. I'll get rid of that. Getting a little messy there. 500 divided by 50, right? Both end in 0. So what is 50 divided by 5? That is 10. So x is 0, y is 10. So let's graph that. 0, 10, we don't move it all left and right. We go up 10, right? This was 8. That means 10 is right here. So to get the graph for this equation and the context, connect those 2 dots. This represents the graph for this situation. Okay, so hopefully not too bad, right? We determined variables for unknowns. We wrote the equation in standard form, and then we found the answer from there. Okay, all right, we're going to quickly go through the last page, 297. Okay, For this, it says we're going to identify the slope and the y-intercept for each one of the problems that we have. We'll say that everything on the right side is a u-do, everything on the left side we'll complete. So this is in slope-intercept form. So the slope is 11, or 11 over 1. And the y-intercept is -9. It does tell us to write the y-intercept as an ordered pair. So that is 0, -9. Okay. And then here, right, we know that the slope is 6. This is in point slope form. Right, you don't have to rewrite this, but just so that we kind of refamiliarize ourselves with this. In order to find the y-intercept here, you do have to simplify. So this is y plus 9 equal to 6x, and then multiply 6 times -3 is -18. And to get the final answer, you'd have to get y by itself. So this in slope-intercept form would be y equal to 6x minus 27, right? -18 minus 9. So the y-intercept, actually we should put b. I should have put b right here. Sorry about that. That's 0, -27. All right, and the last one, this is technically in slope-intercept form. If I were to rearrange it, maybe it seems like it's more. If I were to switch the 3, the placement of the 3 in the -1/2 x. The slope, -1/2. The y-intercept, 0, 3. Okay, and to finish up this lesson, we have different forms here. We're going to talk about when is it best? When is it best to use whichever form? I'm not going to go through the examples. We've already seen those. But the advantages. You use point slope form when you're given the slope and a point x1, y1. We use slope-intercept form when the slope is known and a specific intercept that is the y-intercept. Okay, and then we use the standard form when we can determine both intercepts. We'll put it in plural. Determine both intercepts of the line by substituting, I'll abbreviate here, substituting 0 for x and y. And that wasn't too bad, right? Because multiplying by 0 is just 0. All right, we'd have to go through, we're skipping talk to talk. All these things are just cards from a previous activity. But on page 303, you're going to do numbers 1 through 3. They have different parts, but let me know if you have questions on that. So numbers 1, 2, and 3.